On the second one here, notice that I've changed these little percentages a little bit so that it can mimic the one in our presentation here. So I'm going to keep track over on the right, even though you won't be able to see it because of the screen here, but you'll be able to see the count all together on our video screen. So let's start with our first spin and see how it's different. So we got pink first. Then we got blue. Another blue. Pink. A pink. Blue. A lot of pink and blues here. Pink. And blue. Not a single gray. Goodness. So our tally chart says that of the blue ones, we got 5. Of the pink ones of our trial, we got 5. And then of the gray, we got 0. All right, let's bring it back to our presentation. Just a couple of quick remarks here about the different, these two pieces here. Notice that there are equal amounts of pink, blue, and gray, and here it was offset a little bit. Since all the outcomes are the same, we would call this a fair spinner, or this would be an unfair spinner since they don't all have the same outcome or possible outcome as the rest. So going to the next room here, write the probabilities based on your experiment with the two spinners. So the first one here, we ended up with 3 out of 10 happening to be blue, or 30%. Okay, or pink, I'm sorry, 1 out of 10. So 10%. The blue, therefore, was the 3 out of the 10. And that gave us 30%. And then the gray was 6 out of 10, or 60%. Okay. The pink and what I would say the unfair was 5 out of 10, which gave us 50%. And the blue also gave us 5 out of 10, or 50%. And then we had 0% for gray because we had 0 out of 10. Now, what we should have expected was, because this is equally split into thirds, that we should have gotten 33 1/3% for each one of these. Each one should have been 33 1/3%. Here I set my pink to be 66.6%. I set my blue to be 25%. And I set my gray to be 8 1/3%. Okay. Altogether, it should have been 100%. Now, when I compare my pieces to each other here, I can see that the only one that kind of came close in our experiment was the blue. Otherwise, the pink and the gray were way offset from each other. In the unfair one, we should have seen more pink percentages, but it looks like pink and blue were nearly the same, or they are nearly the same. They should have been a little more spaced out in their percentages. And gray should have happened the least amount. Still a little, I should have at least come up one time, but such is luck here. Jesse tested a spinner and recorded how many times each color occurred in the frequency table below. Find the experimental probability of each color. So it looks like we have a total times that he had spun the spinner was 7 plus 3, which is 10, plus 2, which is 12. So the orange turned out to be 7 out of 12, and the yellow turned out to be 3 out of 12, or 1/4. And the green ends up 2 out of 12, or 1/6. Now, when I try to decide which spinner it is, look, this one's equally distributed into thirds. And these aren't 1/3 or even close to. Notice that when I compare all of the probabilities here, the orange came up the most, and the yellow and the green came up about the same. So I would say that Jesse probably was using spinner B for his experiment. We know that the theoretical probability of an event is the ratio of favorable outcomes to all possible outcomes. There are 7 cherry, 3 lemon, 6 lime, and 4 orange Juicy Splash fruit chews in a bag. If we pull out a fruit chew at random, what is the probability that we will get a lemon or a lime fruit chew? So let's identify the probability of getting the cherry, the orange, the lemon, and the lime. Total possible outcomes we have are 20 when I add all of the different flavors together. So a cherry would be 7 out of 20, or 35%. Achieving a lemon would be 3 out of 20, or 15%. The orange is 4 out of 20, or 20%. And the lime is 6 out of 20, or 30%. We're curious about a lemon or a lime. So I will take the probability of lemon and add it to the probability of lime. So 3/20 plus 6/20 gives us 9/20, or 45%. What is the probability we will not get a cherry? So we want to know the probability of not cherry. So that would be the probability of a lemon or lime or orange. So then I can add their probabilities together. Lemon is 3/20, plus lime is 6/20, plus orange is 4/20, for a total of 13/20, or 65%. Similarly, we can see that getting a cherry, as listed above, is 35%, or 7 out of 20. Notice that the probability of a cherry plus the probability of not getting a cherry is equal to 100%. These are what we call complementary events. Complementary events add up to one whole, or 100%. Let's take a look at our bag of marbles here. Let's identify the probability of obtaining a purple, not purple, and I have another way to show you about obtaining a not purple, and then a purple or a green. So it looks like together I have 5 different marbles. So 3 of the 5, or 60%, are purple. Those that are not purple then are 1 minus that of being purple, which is 5/5 minus 3/5, which is 2/5. Or we could use percentages. 100% minus those that are purple gives us those that are not purple, so 40%. Purple or green. 3/5 are purple, plus 1/5 which are green, so a total of 4/5. Which equals 60% plus 20% equals 80%. So 1/5 is the 20%. We can add the theoretical probabilities of 2 events to find the probability that one event or the other will happen. The probabilities of complementary events add up to 1. Theoretical probability of an event is the ratio of favorable outcomes, what we want to happen, to all the different possible outcomes. In a bag with 3 pink marbles, 1 white marble, and 4 green marbles, let's find the probability of not pulling a white. Altogether, it looks like I have 8 marbles. So the probability of getting a pink is 3/8, probability of getting a green is 4/8, and the probability of getting a white is 1/8. We want to know what the probability of getting not white is. So not white would be pink or green. So 3/8 plus 4/8 is 7/8, or 87.5%. When spinning this spinner, what is the probability of getting a 2 or a 6? The probability of 2 is 1 out of 9. The probability of getting a 6 is 1 out of 9. So the probability of 2 or 6 is 1/9 plus 1/9 equals 2/9, or 22.2%. Select the answers that represent complementary events for the spinner above. The probability of getting a 1 and the probability of not getting a 1. So we know that the probability of getting any number is 1 out of 9. So the probability of getting a 1 is 1/9, and the probability of not 1 would be 1, 2, 3, 4, 5, 6, 7, 8/9. Since they both add up to a 100%, this is complementary events. The probability of getting a 6 and the probability of not getting a 6. So the probability of getting a 6 is 1 out of 9. The probability of not getting a 6 is 1, 2, 3, 4, 5, 6, 7, 8/9. Since 1/9 and 8/9 gives me 100%, these two are complementary events. The probability of getting a 1, 2, or 3, and the probability of getting 4, 5, or 6. The probability of getting a 1, 2, or 3 is 3/9. The probability of getting 4, 5, or 6 is also 3/9. This is not a complementary event because we do not add up to 100%. 3/9 plus 3/9 is only 6/9. The probability of getting an even and the probability of not getting an even. The probability of evens is 1, 2, 3, 4/9. And the probability of getting a not even is 1, 2, 3, 4, 5/9. Since the probabilities add up to 100, these two make up a complementary event. On a standard six-sided number cube, find the probability of not getting a 3. So the probability of not getting a 3 would be 1, 2, 4, 5, or 6. So 5, 6. Or 1 minus the probability of getting a 3, which would be 1 minus 1/6. So 6/6 minus 1/6 is 5/6. Roll a 2 and win a prize. Brooke wants to be sure she has enough prizes for 60 to 90 players. The probability of getting a 2 rolling a dice is 1/6. The total observations is between 60 and 90 players. So I'm going to create a table here. We expect that 1 out of 6 times we will get a 2. We need to multiply that times the minimum number of plays, which is 60. Well, 6 times 10 is 60, so 1 times 10 is 10. The maximum number of plays is 90, and 6 times 15 gives us 90, so 1 times 15 is 15. Theoretically, Brooke will need between 10 and 15 prizes if there were between 60 and 90 observations. Pick a pink marble and win a prize. The total number of observations is 80. The probability of getting a pink is 2 out of 5. So 2/5 equals how many out of 80? Since 80 is our observations or the number of trials. Well, since 5 times 16 is 80, 2 times 16 is 32. This particular game, we would expect to need 32 prizes.